Somewhere in the universe, a star is dying right now. In its final, fleeting moments, it will unleash more energy than our own sun will produce in its entire 10 billion-year lifetime. This spectacular death is known as a supernova, a cosmic explosion so immense, so powerful, that it literally reshapes the universe itself. These are not just distant fireworks. They are the engines of creation. Stars are born from vast, swirling clouds of gas and dust. For millions, sometimes billions of years, they exist in a delicate dance, a perfect balance between the crushing force of gravity pulling inward and the explosive energy of nuclear fusion pushing outward. They burn through their hydrogen fuel, shining brightly across the cosmos. But for the most massive stars, this fuel is finite. When it runs out, the music stops. Gravity, relentless and unforgiving, finally wins. The star's core collapses in on itself. In less than a second, an event of unimaginable violence is triggered. The core implodes, then rebounds, launching a shockwave that tears the star apart in an explosion that can outshine an entire galaxy of billions of stars. This cataclysmic event isn't a one-size-fits-all phenomenon. Broadly, we see two main types of supernova. The first is type Ia. This happens in a binary system where a dense, compact star, called a white dwarf, acts like a cosmic vampire, siphoning material from a larger companion star. When it steals too much, it crosses a critical threshold and detonates in a thermonuclear explosion of incredible uniformity, which is why astronomers use them as standard candles to measure cosmic distances. Then there's Type 2, the classic death of a massive star, collapsing under its own immense gravity, as we just described. Each type of explosion leaves behind a ghostly, ultra-dense remnant. Depending on the star's initial mass, this could be a rapidly spinning neutron star, a city-sized object with the mass of a sun, or if the star was massive enough, a black hole, a point of infinite density from which not even light can escape. In 2015, humanity witnessed one of the most brilliant light shows in cosmic history. Astronomers recorded an explosion designated ASASSN 15LH. It wasn't just bright, it was mind-bogglingly luminous, a staggering 50 times brighter than our entire Milky Way galaxy, with all its 200 billion stars. For weeks it shone like a cosmic lighthouse across the void, a beacon visible from billions of light years away. The exact cause is still debated, but one leading theory suggests it was something even more exotic than a typical supernova, the birth cry of a supermassive black hole, caught in the act of shredding and consuming its own parent star. A true Titan's farewell. Now look at your hand. Consider the iron in your blood that carries oxygen, the calcium in your bones that gives you structure. Every single atom of those elements, and heavier ones like gold and silver, was forged in the heart of a supernova. Our sun is not massive enough to create these elements. They were cooked in the unimaginable heat and pressure of a dying star's final moments and then scattered across space by the explosion. Without these cosmic detonations, the heavy elements needed for rocky planets, for oceans, and for life itself would not exist. Supernovas are the universe's ultimate recycling program. They are the bridge between death and creation, transforming stellar ashes into the building blocks of you and me. The influence of these explosions extends far beyond just seeding the cosmos with elements. In some galaxies, especially active star-forming ones, supernovas occur so frequently that they sculpt their environment on a galactic scale. The powerful shock waves from these explosions ripple through space, compressing nearby clouds of gas and dust. This compression triggers gravitational collapse in those clouds, sparking the birth of new generations of stars and planetary systems. In this grand cosmic ballet, supernovas are both the destroyers and the architects of the universe. They are the catalysts for a cycle of destruction and rebirth that has continued for billions of years, shaping the galaxies we see today. But the universe always has something more extreme up its sleeve. Even more powerful than supernovas are the terrifyingly energetic events known as hypernovas. These are the death throes of the true giants of the cosmos, stars more than 30 times the mass of our sun. These explosions are so powerful they can produce gamma-ray bursts, the most energetic phenomena observed in the universe since the Big Bang. A single, focused jet of radiation from a hypernova could be catastrophic, potentially sterilizing any planets with life that lie in its path, even thousands of light years away. It's a stark reminder of the sheer power and violence of the cosmos. And so, we arrive at the universe's most beautiful paradox. Supernovas are death, but they create life. They are acts of ultimate destruction, yet they are the engines of cosmic creation. Each brilliant flash we see across the vastness of space is a new chapter being written in the grand story of existence. So, the next time you look up at the night sky, remember that you are not just looking at distant lights. You are looking at the furnaces that forge the very atoms you are made of. You are a child of the stars, born from the ashes of a dying sun. Thank you so much for joining us on this cosmic journey. If you enjoyed this and want to explore more wonders of the universe, please hit that like button and subscribe for more. We'll see you in the next one.
Cosmic secrets revealed. Beyond time, beyond space, beyond imagination.